got the liquid nitrogen here, and I've got this balloon that I've filled with air. So there are gas molecules inside this balloon, and they were probably warmer than room temperature when I blew them into the balloon. Now they've had some time to be at room temperature. We could talk about how that happens if you're curious in a little bit, but let's say this is room temperature air. Those molecules are still zinging back and forth. 300 to 400 meters per second are the speeds of those molecules. They're very fast, but they're very small. That's what gives the balloon its shape. There's particles of air on the inside smacking into the inside wall of the balloon, and particles of air on the outside smacking into the outside. When they are roughly the same temperature, they're hitting with roughly the same force, so the balloon doesn't get any bigger or any smaller. When I cool this balloon down, it's a dramatic version of what happens when you buy a balloon in February for a birthday and you take it out of Schnucks into the cold air of the parking lot, and that balloon, I say, gets sad. Let's make this balloon sad and have a more drastic version of what happens to a balloon in February. So I'm just going to pour the liquid nitrogen on it. Slowly, slowly, slowly. The cold liquid nitrogen is now in contact with the balloon, and it cools the gas inside down. And when that happens, we can see the effect of those particles slowing down. When those particles inside, the gas molecules inside, go slow, they can't push on the balloon as hard, so the balloon shrinks in size, because I have more push from the outside squeezing the balloon down than I have from the inside pushing out, because they're cold and moving slow. So slow things shrink in size because those particles don't go as fast. As it warms up, we see that the balloon is now increasing in size again because the molecules are going faster and they can now push on the balloon again. So it's not that the balloon deflated. I would never use that word to describe what's happening because no air left the balloon. You see, now the air came back. I didn't have to blow it back up. I didn't undo that knot. It didn't deflate. It just got cold, and therefore the molecules got slow and they couldn't push the balloon. So we can see that temperature is really just a description, numerically, quantitatively, of how fast on average things are going. When you touch something hot, it's just that those particles are moving around really rapidly. When you touch something cold, those particles are not moving around really rapidly. That's all that's happening there. Now, when we